Hey, Earth scientists, we're going to take a look at your exam review for Earth and Environmental. And first, we're going to look at the test specifications. So you can see on this chart that there are 40 multiple choice items that are operational. That means that 40 items are going to count towards your score, and then 5 field test items will be embedded in your exam as well. So that gives you a total of 45 items that you'll be answering. So again, remember that the field test items are not identified in any kind of way. They're just all going to be mixed in. So approach your exam as if all of the items count, because you don't know which ones are field test items and which one are your operational items. So you'll have 120 minutes to answer all your items, about 2 hours, and that should be plenty of time. So this is the breakdown of your exam, and you can see that there are a couple more that are weighted a little more heavily: ecology, space, lithosphere, natural resources, human impact. Those are going to be the ones that are weighted a little more heavily. And then you've got water kind of broken up into a couple of sections: weather and atmosphere, climate change, and sustainability and conservation. So make sure that as you're studying that you do look over all the information, but just kind of keep in mind that there are certain ones that are going to be weighted a little more heavily. So I have a review sheet for you, and if you pick that up, then feel free to jot down notes as we go over this information. And if you didn't, then this video should still be helpful in explaining this information to you in a very succinct, clear way. So why is it important that the Earth's axis is tilted? It's important to us because it allows for the seasons to occur. So that that tilt of the Earth is going to enable us to have different amounts of access to sunlight and heating. So that differential heating is going to cause the seasons. So here is a released item that I'm going to walk you through a few of these as we're looking at this video, so you can kind of see the thinking behind it. So how does the tilt of the Earth's axis affect the seasons? Literally, that's just what we were looking at. So how does the tilt of the Earth's axis affect the seasons? You know that it's going to cause the seasons, and you know that it's going to cause there to be differential heating. There's going to be certain amounts or certain spaces on the Earth that's going to receive more sunlight at certain parts of the year, and other parts of the Earth are going to receive less sunlight. So if you look at your answer choices here, A is the correct answer because it changes the amount of direct solar energy that is reaching the surface of the Earth. It does not change the speed of rotation of the Earth. It doesn't deflect radiation. It doesn't change the rate of chemical reactions. So if you look at each answer choice very specifically after thinking about what you know about that topic, then that will help you to more clearly answer the question. When the Northern Hemisphere experiences summer, why does the Southern Hemisphere experience winter? So basically across the equator, you're going to have a flip of the seasons, and that's because you're going to have more direct sunlight that is going to be that the Northern Hemisphere is going to be receiving, while the Southern Hemisphere is going to be mostly in shade. It's going to be receiving indirect sunlight. So that's why across the equator, you're going to have summer up here, and then below in the Southern Hemisphere, you're going to have winter. If it's summer in the Northern Hemisphere, which statement is true, so if it's summer in the Northern Hemisphere, it's going to be winter in the Southern Hemisphere. So look at your answer choices and see which one of those best fits that statement. So Earth has changed the tilt of the axis by 20 degrees due to its revolution. The Earth isn't randomly changing the tilt of its axis. It's winter in the Southern Hemisphere due to the tilt of Earth's axis. Yes. It's summer in the Southern Hemisphere due to the tilt of Earth's axis. Well, if it's summer in the Northern Hemisphere, then it's not going to be summer in the Southern Hemisphere. It's going to be the opposite. Earth has reached its closest point to the sun due to its revolution. No. Next statement, contrast the terms rotation and revolution. So rotating and revolving. I put this little graphic here to help you see the difference. So rotating is just spinning around. So the Earth in this picture is just rotating, it's spinning around. And then revolving is actually going around something. So the moon is going around the Earth in this example. The Earth will be, over time, going around the sun. And Here's a little funny way that you can remember that. Think about a funny Miss Owen science shirt. The rotation of the Earth really makes my day. Haha, because the rotation makes night and day. So I don't have that shirt, but I would love to own that. Which natural phenomenon occurs as a result of Earth rotating on its axis? The Earth spinning around causes there to be night and day. Barycenter. So barycenter is the center of mass, looking at multiple celestial bodies. So the example, if you try to like balance a ruler on your finger, when you are able to balance it, then you have your finger directly aligned under the center of gravity, where if you try to put your finger under the ruler over here, then more mass is going to be on this side, so it's not going to be balanced. So just remember, like the sun, for example, here, Jupiter here, the barycenter is not necessarily going to be like the exact center of the solar system. It's going to be the center of mass, the center of gravity between those two objects. So again, we looked at the example of like a sledgehammer. So if I try to balance a sledgehammer on my hand, I've got to balance it. I've got to hold the sledgehammer at the center of gravity, or else that sledgehammer is going to fall down and break my toes. So it's just the center of mass between different objects. Nutation is just oscillation, so it's just the wobbliness of the Earth on its axis. So the nutation is this kind of wobbly motion here. Precession is going to be this kind of spinning top motion. So the nutation is going to occur within the precession here. So precession is going to be caused by the gravitational pull of the sun and moon on the Earth. So if you imagine the Earth as a spinning top, it over 26,000 years makes this kind of motion as the Earth is spinning. So you can see like a little spinning top here as it spins. It's still spinning, but it's just kind of has a circular variation within that. Number 4D, ellipsoid versus spheroid. So the elliptical shape is going to be used more as a reference to GPS determining longitude and latitude. So it's going to use this to as a method of collecting data. So our longitude and latitude. The spheroid, the oblate spheroid shape, is a reference to Earth's bulge at the middle. So this occurs because the Earth is spinning, and also materials are able to move on our surface, like earth materials and water, rock, that kind of thing. So as the Earth is spinning, that allows for this bulge. If the Earth weren't spinning, then it would be more of this spherical shape, that standard kind of sphere. Different types of tides, spring tide and neap tide. So an easy way to remember neap tide is 90, neap and 90. So a spring tide is going to have the sun, moon, and Earth all lined up. So you can see that occurring there. And then this is a neap tide and another spring tide and another 90-degree neap tide. So those tides are going to be one due to the location of the sun, moon, and the Earth. And then also when you have a spring tide is going to be the biggest difference between the tides, the biggest difference between low tide and high tide, because it's going to be pulled on basically in one direction. So it's being pulled straight across. So that means that this upper and lower area, the northern and southern parts of the Earth, are going to have basically like shorter or lower tides. Whereas with a neap tide, the low and high tide are going to be a little bit closer. So the low and high tide are going to be not as great of a difference between them, because you have water basically that's being pulled on in both directions. So it's being pulled this way and this way. So how does the straight alignment between Earth, Sun, and the Moon impact the tides on the Earth? So a straight alignment is going to be referring to the spring tide. So it's going to produce the greatest change, the greatest difference in high and low tides because you have the moon, earth, and sun all lined up. And so that means it's tugging basically east and west on the water. So it's going to produce bigger changes in the tides. This is looking at nuclear fusion versus nuclear fission. So where is nuclear fusion going to occur? Nuclear fusion is going to occur in stars. It's what's going to allow for that radiant heat. And how does it occur? So fusion, your stem, or the word part, fuse, refers to like putting things together, smashing things together. So atoms are fused together. So fusing together hydrogen and helium is going to help stars to generate that radiant energy, whereas with fission, nuclear fission, your stem fizz refers to splitting apart. So nuclear fission would occur like in a nuclear reactor, so that's how nuclear power is generated. So in nuclear power, nuclear energy, it's going to be splitting apart uranium atoms, for example. So you start with one and then it splits into two. So you can use your stems to help you on that to remember the difference between those. So it just describes the difference between nuclear fission and nuclear fusion. So your answer choices here have two parts in them. They have your first statement and then they have your second statement. So you want to make sure that both parts of the answer choices are correct when you choose these. So we know that fission is splitting apart, fusion is smashing together. So nuclear fission is a process that produces radiant energy of stars. No, fusion does that. Nuclear fusion splits a heavier nucleus into smaller nuclei. No, that would be describing fission. Nuclear fission splits a heavier nucleus into smaller nuclei. That would be a correct statement. And nuclear fusion is the process that produces radiant energy of stars. That's correct. So that both parts of that statement are correct. Nuclear fission produces energy in the core of the Earth. No. Nuclear fusion produces energy in nuclear power plants. No. Fission would be doing that. Nuclear fission produces energy in nuclear power plants, yes, and nuclear fusion produces the energy in the core of the Earth, no. So make sure when you have long, wordy answer choices like that, that you look at all parts of the statement. What are the three types of rocks in the rock cycle? Igneous, sedimentary, metamorphic. And how are each of those formed? Well, igneous, IGN, your stem, refers to fire. Igneous rock is going to be volcanic rock. It is from rock that is so hot that it has melted. So if you have extrusive volcanic rock, then it has formed on our surface. If you have intrusive volcanic rock, then it has formed inside of our surface, deep underground. So igneous is going to be made from magma or lava. Sedimentary rock is going to be rock particles smushed together. And remember, it can contain remains of living organisms, remains of plant or animal, and that is going to be called a fossil. And then metamorphic rocks are going to be from some kind of change that is usually going to be due to heat or pressure, but it can be from chemical reaction also. So metamorphic rocks are going to be when you have an existing rock and then it changes. So limestone, for example, is a type of sedimentary rock, but when limestone metamorphoses, then it turns into marble. What's the difference between physical and chemical weathering? Physical weathering is going to be physically breaking rocks down. So that could be through abrasion, which is where you have basically kind of like sandpaper being applied to rocks, although it's not using sandpaper, it's using different agents of weathering. So it could be sand, it could be water. And that's one example of how rocks, river rocks form. They get so worn down by other rocks abrading against them, or those rocks being tumbled in a river, for example. Ice wedging is another example. So water you have water kind of pulling up in a crack in rock, and then as that water freezes, it's going to expand, and then when it thaws, it melts, and that continually happens over time is going to crack open the rock and make even a larger fissure. Different agents of weathering like wind can form formations like this. A sandstone make that layer of sedimentary rock into an arch. And then plants and animals can also affect rock formations by causing cracks in them or animals digging into the ground and that sort of thing.